An example of a plane is this concrete thing right here. It's a plane because it's one flat surface. So I'm going to label this plane, and then we'll call it R. A whiteboard is an example of a plane because it's one flat surface, and many dots and lines can lie on top of it. An example of a point would just simply be that. Just a dot, and it represents one spot, like on a plane or a line. It can also be on a line, but this is on a plane. We'll call this B. Point B. The top of the Washington Monument is an example of a point because it's one specific spot. A line would be this. This is a line segment. The difference between a line segment and a line segment has two endpoints that stop the line. A line goes on forever. We'll call this line segment A, B, which can also be written as that. That's how you would abbreviate it. This laser, which goes from a dome to the moon, is a line segment because it starts at the dome and ends on the moon. Coplanar lines or coplanar points are either 2 points or 2 lines on the same plane. They can be intersecting or not. It can be 2 or more. So like those would be coplanar points. We'll call those C and D. And these could be coplanar lines. These two cities are planes because if you pick a plane through those two cities, they would be on the same plane. This is an acute angle because it is less than 90 degrees but greater than 1 degree. So it goes from 1 degree to 90 degrees. It can be anywhere in there and is classified as acute. But when it reaches 90 degrees, it's not an acute angle anymore. The pieces of wood holding up the top of the fort are acute angles because they're less than 90 degrees. This is an obtuse angle because it's greater than 90 degrees. Obtuse angles can go from 91 degrees to 179 degrees. Once they go past 179, it's a 180 degree angle, and that's not obtuse anymore. And if it's 90 degrees, it's a right angle, not an obtuse angle. The wings on this fighter jet form an obtuse angle because they're greater than 90 degrees, but less than 180 degrees. This is a straight angle because it measures exactly 180 degrees. If it's any less or any greater, it's it's obtuse. It's no longer a straight angle. And a straight angle is formed by 2 opposite rays, which go in either direction, one that way and one that way, to form a straight angle. A ruler is a form of a 180 degree angle or a straight angle because it's one straight line. This is a 90 degree angle because it is exactly 90 degrees. It's also a right angle, but this measures 90 degrees. If it's any more or any less, if it's any more, it's obtuse. If it's any less, it's an acute angle. Every angle on the outside of this building is a 90 degree angle because it is exactly 90 degrees. It can also be referred to as a right angle. When you're looking for the hypotenuse of something, it's pretty much always going to be a triangle. And the hypotenuse is basically the longest side. Now with this one, it's pretty easy to tell that it's that one. But if you didn't know for sure, you could take out a ruler and measure. That one's 8 inches. This one is, it's 13.5 inches, and then this one is 16.5. So this is definitely the hypotenuse because it's the longest side, and it's also opposite of the right angle. With a right triangle, if you have a right angle, which is a right triangle, it's always opposite of the right angle. So that's a quick, easy way to tell the hypotenuse of something. This is a right triangle, and the hypotenuse would be the top line, or the top edge, because it's opposite the 90 degree angle. When looking for the circumference of a circle, you're looking for the distance all the way around it. So what you do is you find the radius, which in this case is 0.5 inches. This is not to scale. So after you know the radius, you find the diameter, which is all the way through the circle, through the midpoint. The radius is from the midpoint out to any edge, any point on the edge. The diameter is it makes a 180 angle there, but it stops at the edge. And so this would be 1 inch, because the radius is half of it, so you just multiply it by 2. Then you multiply the diameter by 3.14, or you multiply it by pi, but this is an abbreviation for pi, so then you get the diameter, or the circumference is approximately 3.14 inches. The distance around the equator is the circumference of the Earth. To find the reflection of a point, if I had a point at 2, 2 on a coordinate plane, it's easiest to find this on a coordinate plane, otherwise it's pretty much impossible, or not impossible, but really, really, really difficult. So at 2, 2, if I wanted to reflect it over the x-axis, it would be at 2, negative 2, right here. The mountains that look like they're on the water is a reflection of the real mountains, and it's reflected over the water line, which in this case would be, or on a coordinate plane, it would be the axis. To find the rotation of a triangle, what you do is you decide either to reflect it over the y, or rotate it over the y or x-axis. In this case, I'm going to do it over the y-axis. What you're going to do is you're going to almost, if you had a triangle cut out, you'd just pick it up and kind of rotate it like that. Just pick it up this point. If you're rotating it by this point, which you are because it's closest to the origin, you kind of pick it up and hold that point down and kind of bring it, it'd be still right there. This point, you're reflecting every point over the axis that you're rotating over. So that point's like that now. Now this point's all the way over here. And then that point is all the way over there. So now your triangle looks like this. The wings on a windmill rotate over and over and over again, just like the triangles on the graph. When translating something to another spot on the coordinate plane, it's not like rotation, where it looks completely different. The triangle will still look like this at the end. If it starts like that, it'll look like this at the end, no matter which way we push it. We're basically pushing it. If we were to push it 3 spaces to the right, we would move every single point on the triangle 3 spaces to the right. So this one would go 1, 2, 3. That's all it does. This one would go 1, 2, 3. Right there. Then this one would also go 1, 2, 3. Then it looks like that. This is one example of a transition, but another example is just if you slide something across the table, that's also an example.